Welcome to a reading from the Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University, 1663 to 1993, by Robert Bruen, as read by his son, Garth Bruen. Chapter 4, The 20th Century, Physics. Up to now, most scientists have been too occupied with the development of new theories that describe what the universe is to ask the question, why? On the other hand, the people whose business it is to ask why, the philosophers, have not been able to keep up with the advances of scientific theories. In the 18th century, philosophers considered the whole human knowledge, including science, to be their field, and discussed questions such as, did the universe have a beginning? However, in the 19th century and the 20th century, science became too technical and mathematical for the philosophers, or anyone else, except a few specialists. Stephen Hawking. Background. As the 20th century draws to a close, the events and discoveries that have occurred in it are almost impossible to comprehend. The airplane, computers, quantum theory, relativity have all had an enormous impact on our daily lives. The Lucasian professors have contributed to this flood of knowledge and invention during the past 100 years. Besides, the social events that have transpired in this century are overwhelming. Wars have taken place that have been destructive to a magnitude never before imaginable. The atomic bomb was conceived, developed and deployed during this century. Deaths have been measured in tens of millions. New nations have been formed, flourished, and have crumbled. The Middle East has been reshaped once again as the world struggles over the holiest ground in the Western world. Small and unimportant nations have risen to great power, only to be crushed and then rise again. The world has experienced great economic depression, thrusting millions into poverty and hardship. At the same time, the world's great wealth has been concentrated in the hands of individuals who are not kings, rulers, or empires. It has been the century of superpowers that disturb the rest of the world every time one takes a deep breath. The technological revolution at the end of this century appears to be having the same effect as the Industrial Revolution almost 2 centuries ago. On the one hand, progress is providing new opportunities and more conveniences, and on the other, it is causing great disruption in society as people try to adjust to swift changes in economic upheaval. Britain's government still keeps the monarchy as a figurehead, but daily affairs are run by a prime minister and parliament. The issues that consume their time are the usual economic ones, with political problems caused by the Irish Republican Army. There is much to do with the attempts to unify Europe, with struggles over political sovereignty, central banks, and common passports. In many ways, though, the problems are not so different from 300 years ago. They are just on a larger scale. Cambridge University today is a world-class university, proud of its heritage and having grown in the number of students enrolled, as well as in the breadth of studies offered. The Royal Commission of 1919 published a report in 1922 with recommendations that had dramatic effects on Cambridge. The 4 recommendations were aimed at the heart of the university. The first recommendation created the Regent House, or House of Regents, as called earlier, which instructed how the university was governed. The new organization favored those who were in residence at the university at the expense of those who had left but still had their names on lists that gave them voting rights. The second recommendation looked hard at the organization of teaching and research, established new faculties, faculty boards, and teaching offices. It also set proper salaries for teachers. The reorganized fellowships placed a premium on research. The Commission opposed the idea of a university focused completely on the undergraduate experience. Research was considered necessary to move the university into modern times by improving the university overall. The third recommendation concerned access by the poor. The approach was twofold. First, to strengthen local scholarships, which took time, but helped, and second, to look carefully at how the university handled its money, with the objective of reducing expenses to make a university education more affordable. A university with its roots in the Middle Ages offers many special features, but the management of money does not seem to be one of them. The accounts and fund management underwent significant modifications and improvements. The final recommendation was not successfully implemented. The commission advised the inclusion of women in the university, limited to 500, but they were not to be admitted to the men's colleges. It also recommended that women not be allowed to hold any office of authority. Even this lukewarm approach was ignored for many years, although Oxford had already made the change. There had been several votes at Cambridge previous to the commission, and all were overwhelmingly opposed. Ultimately, the change was driven by the undergraduates, not the administration. Women were admitted to degree status in 1948, but it was not until the 1960s that true equality was granted. Toward the end of the century, the student body is composed of over 10,000 undergraduates, over 3,000 full-time graduate students, and more than 1,500 part-time graduate students. There is a noticeable increase over the undergraduate population of 3,000 in 1900. During the 20th century, the Lucasian chair had been one of physics, with Sir James Lighthill exploring fluid mechanics in the tradition of George Stokes. In 1992, a professorship of fluid mechanics in honor of Sir Geoffrey Taylor was established in the Department of Applied Mathematics and Theoretical Physics, the same department that claims Stephen Hawking, the current Lucasian professor. The earlier part of the century saw the establishment of the world of quantum physics and relativity. The end of the century is the world of joining these two ideas into one theory to explain everything. The Lucasian chair holders participated in the understanding of quantum mechanics first, with Paul Dirac, and now with theorist Stephen Hawking, working in cosmology with time and quantum gravity. Joseph Larmor took the Lucasian chair the same year that the Wright brothers flew at Kitty Hawk, 1903. 2 years later, Albert Einstein published his first work on relativity. At the end of the century, Stephen Hawking is postulating black holes, other universes, and a future full of wonders yet to be discovered. In less than 70 years from the date of man's first flight, humans walked on the surface of the moon. The pace of advancement for this century has been extremely rapid. We now understand the atom to be composed of electrons surrounding a nucleus, composed of protons and neutrons. These atoms in turn make up the molecules that are the basis for life as we know it. The protons and neutrons are composed of quarks that cannot exist in isolation. There are hundreds of particles made of these quarks. At the beginning of the century, the atom was not understood to be composed of different particles. The work of Sir Joseph Larmor and Paul Dirac helped in the growth of understanding of the fundamental makeup of matter. This is also the century that saw the realization of Charles Babbage's vision for a machine to handle calculations. The computer found its way into reality and then into our daily lives. It is hard to believe that Babbage could have ever imagined the capabilities of such an engine. He began with a simple idea of a mechanical machine that would calculate, adding variables and a program to perform the work. In our time, the mechanical has given way to the electronic, but variables and programs are still integral parts of the process. The airplane was not invented by a Lucasian professor, but Sir James Lighthill made significant contributions to the growth of the civilian aircraft industry in Britain with his work on aeronautics. The noise from military aircraft was an obstacle in civilian use. His understanding of noise and noise reduction was an important advance. He was following in the wake of Stokes in the last century with his work in fluid mechanics. In the area of biology, the advances had been incredible. The Human Genome Project has created a map of the hundreds of thousands of genes in the human body. This map is made available to researchers worldwide through computer networks. On a weekly basis, discoveries of genetic causes of diseases and disabilities are announced, along with new types of gene-based therapies. The leaps of understanding that have occurred during the last few decades are in line with the leaps which took place in understanding during the scientific revolution of the late 17th century. Thank you for listening to this segment of the Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University by Robert Bruen. To learn more or support this podcast, go to lucasianchair.org or our Instagram account, Lucasian Legacy.